Namaste and a very good morning to all of you. My name is Mithun. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at multiple linear regression. When we speak about multiple linear regression, the adjective multiple here refers to multiple independent variables. Multiple linear regression is often compared with what is called a simple linear regression. In the case of simple linear regression, you have only one independent variable. But in the case of multiple linear regression, we have multiple independent variables. To see how do we operationalize multiple linear regression, I'm going to use SPSS and with the help of a specific example, demonstrate how to obtain the results of multiple linear regression. Let me go to the file menu, choose the second option, which is called as open. Here, I will click on the very first button, namely data. You can see a lot of files here. I will choose the file which is called as carsales.sav. Let me open this data set. Here you can see the different manufacturers of the cars. You also have different models of personal motor vehicles. You can see variables like sales, resale value, type, fuel efficiency, engine size, horsepower, wheelbase, width, length, curb weight, and fuel capacity. You also have other variables like mileage per gallon. These are some of the important variables that I am interested in. Now, what is the dependent variable here? The dependent variable here is sales. Remember, in linear regression, we can't use a categorical variable. We have to use a scale variable. A scale variable is that variable which has units. When you look at the variable sale, this is a variable which is expressed in dollars here. So the variable sales has a unit. I can use this particular variable as the dependent variable in multiple linear regression. To perform the multiple linear regression, what I will do is click on Analyze menu. I will choose the option Regression. You have a whole lot of options corresponding to linear, corresponding to regression, my apologies. I will choose the second item here called as linear regression. My goal here is to show linear regression. Let me click on linear. Let me maximize the dialog box corresponding to linear regression. Now, I have to specify the dependent variable and the independent variable. In this example, I will choose sales as the dependent variable. And when it comes to the independent variable, let me begin with the variable price. I will first run a simple linear regression and then compare the output of simple linear regression with that of multiple linear regression. So sales is my dependent variable and independent variable will be price. There are a whole lot of options that you can do with statistics tab, plots tab, save, options, style, and bootstrapping. And I am not going to use any of these things. In my subsequent videos, I will explore each of these things in a greater detail. Right now, I want to keep it very simple. I have got a dependent variable, which is sales, and the independent variable here is price. Let me click on the option OK. What you see here is quite interesting. You see R square. R square is the coefficient of determination of the model. R square is popularly called as coefficient of determination. And here you see the R square value being 0.09, which means that 9% of the variation in sales is explained by the independent variable, namely price. As you can see here, the first table gives you description about what is the independent variable that you have taken. The independent variable is price. It also puts a footnote here saying that the dependent variable is sales. But when you look at the model summary, you can confidently say that 9% of the variation in sales is explained by the independent variable price. Is that significant? Look at the ANOVA table and the significance value of the ANOVA table. When you compare the p value or the significance value with 0.05, Since the p-value is less than 0.05, you can conclude that the model is significant. I proceed now to what is called as the coefficients table. Very interestingly, you're getting the intercept term as 93.026. This is the value of the constant or the intercept term. And then we have price. The value of price here is minus 1.452. The heading here is unstandardized coefficients. So the unstandardized coefficient for price is minus 1.452. What does this mean? It simply means that if price increases by 1 unit, sales will decrease by 1.45. I use the word decrease because you have got a negative value. If you increase the independent variable by 1 unit, what is the corresponding impact on the dependent variable? That is what is highlighted by the unstandardized coefficient. When you look at the significance value here, price turns out to be significant because the p-value is smaller than 0.05. And since it is less than 0.05, I can say that the variable price contributes to the model. Now, one problem here is that R square is less. How do you improve the R square? There are multiple strategies that you can adopt to improve the R square value. By adding additional variables, you can improve your R square. By increasing the sample size in the data, you can improve your R square. There are multiple strategies that you can use to improve your R square. I'd like to draw your attention to one simple strategy that you can use to improve or boost your R square. What is that strategy? Pay attention to the dependent variable. As you can see here, the dependent variable that we have used is sales. Linear regression works best when the dependent variable is normally distributed. Have we checked whether the dependent variable is normally distributed? We have not checked that the dependent variable is normal or not. Let's first check whether the variable sales is normally distributed. To check whether this particular variable sales is normally distributed or not, I will click on the Analyze menu, choose the second option, Descriptive Statistics, and here I will use what is called as the PP plot or the probability plot to check whether this particular variable is normal or not. Once I click on this particular option, the dialog box for PP plot opens up. I will choose the dependent variable, not the independent variable. Please choose the dependent variable, that is sales. Let us check whether this particular variable is normally distributed or not. I'll click OK. You can see the dependent variable here. This is the distribution of the dependent variable. And you can see a 45-degree line here. Now, how do we interpret this particular graph? If the distribution of the points lie along the 45-degree line, you can conclude by saying that the variable sales is normally distributed. However, in this particular case, the data points are not lying along the 45-degree line. And since the data points are not lying along the 45-degree line, from my PP plot, I conclude that the dependent variable is not normally distributed. So what if the dependent variable is not normally distributed? If the dependent variable is not normally distributed, what we can do is we can perform the log transformation and then check whether the dependent variable follows normality or not. To check whether to transform the variable, what we can do is we can use the transform menu. The very first option here is compute variable. I'm going to compute a new variable by specifying natural log transformation for the variable sales. I've used the ln function. Ln stands for natural logarithm. I am looking for the variable sales. This is the variable sales. So ln of sales, caps L and small letter n. Now the target variable here will be log sales. So after applying the log transformation, the new variable will be called as log sales 1. Let me click on the option OK. Now, when I click on the data set and scroll to the extreme right, you can see this is the new variable called as log sales. Let us check whether this variable follows normal distribution or not. How do you check this? Please click on Analyze. Second option is Descriptive Statistics. Here, I can choose the option Probability Plot. I will remove the variable sales. This is the original variable, and we found that the original variable did not follow normality. I will choose the variable log sales, the newly created variable after transformation. I'm going to check whether the log transformed values follow normality or not. Let me click on the option OK. Wow. This is how the log transformed values look like. Please look at the heading, normal PP plot for log sales 1. As you can see here, the distribution of the data points is lying along the line. It is not lying exactly on the line, but more or less it lies along the line. If you compare this with the earlier variable, this is the original variable of sales, and there is huge departure of this particular variable from normality. But when I transform the variable, the distribution appears like this, and this variable follows normal distribution. What do you do with this variable? What I will do now is I will go to the Analyze menu, choose the option Regression, and click on the second option, Linear. I had earlier used the variable sales. Sales is not normally distributed, and therefore, let me remove this particular variable. Instead of sales, I will be choosing log sales. Please understand, this is a simple trick. This is a simple technique that we have, that if the dependent variable is not normally distributed in the case of linear regression, usually the goodness of fit will be weak. If the dependent variable follows normality, and I've just now demonstrated as to how you can ensure that the dependent variable follows normal distribution through simple log transformation. Once the dependent variable follows normal distribution, let us look at what is the impact on the model. Let me click on OK. Now, please look at the R square. In this case, the R square looks bright. The R square value has jumped up to 0.30. It has jumped up to 30%. Let me draw your attention to the earlier R square value. When I look at the earlier R square value, that is the model summary, without transformation, you got a R square value of 0.09, which means barely 9% of the variation in the dependent variable was explained earlier before transformation. Now that I have transformed the variable, look at the model summary table. The R square has shot up to 30%, which means that 30% of the variation in the dependent variable, namely sales, is explained by the independent variable price. Very, very important. So if you have to improve your R square, many times people add additional variables. The problem with adding additional variables is that R square sometimes gets inflated, though the variable might not be making a significant contribution to the model. Sometimes people improve the sample size, but that is a costly affair. If you do not want to add additional variables, and if you do not want to increase the sample size, one great and effective, not just effective, but also a very, very efficient way of boosting up your R square is to check whether your dependent variable follows normal distribution. Linear regression works best when the dependent variable follows normal distribution. So here, 30% of the variation in the dependent variable is explained by price. And when I look at the significance value, the significance value or the p-value is less than 0.05, which means that this particular variable, this particular model is significant. Let me look at the unstandardized coefficients. Like before, you're getting a negative value for price, and it is a significant contribution made by the variable price. Why do I say that price is a significant variable? I'm saying that price is a significant variable simply because the p-value for price is less than 0.05. Since the p-value is 0.000, which is less than 0.05, I can conclude by saying that price is a significant variable. Now, this is an example of what is called as simple linear regression. Now, if I have to look at a realistic scenario, you cannot estimate the values of sales just by looking at the variable price. There are other factors as well which influences the dependent variable. If you include all these variables into your regression model, what happens to the model summary? To include all the variables, what I will do is I will click on the option Analyze, choose the option Regression. Second item here is Linear. This opens up the earlier dialog box. I'm building the regression model with a log transformed sales, and the independent variable is price. What I will do is I will choose vehicle type, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, and fuel efficiency. So all these additional variables I will push into the independent list. Now, this is a case of what is called as multiple linear regression. I repeat, this is a case of multiple linear regression. As you can see here, I have included approximately 10 different variables, that is price, vehicle type, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, fuel efficiency. All of these variables will influence the variable sales. And when it comes to variable selection, please look at this default method, which is called as the enter method. So I will be getting the coefficients for all these variables when I choose the enter method. So when you include multiple independent variables, this becomes an example of multiple linear regression. Earlier, I had built the model with only price. Now I will be choosing multiple variables. Let me choose the option OK. You can see here the variables entered. Which all variables have I entered? All these are the variables that I have entered, from fuel efficiency all the way up to horsepower. All these are the vehicle characteristics which I believe will influence the dependent variable. The dependent variable is log sales. Now, please look at the R square. R square is a goodness of fit measure. I repeat, it's a goodness of fit measure. It's also known as coefficient of determination. Now, the R square is 0.486. Let me draw your attention to the earlier model summary table. When you look at the earlier model summary table, the R square value was 0.30 or 30%. Now, the R square value from 30%, this 30% you got when you built a simple linear regression. Now, when I look at the new model summary table, the R square has jumped from 30% to 48%. What does this 48% mean? 48% means that 48% of the variation in sales is explained by the set of independent variables that we have included in the model. So 48% of the variation is explained by all these variables like fuel efficiency, length, price in thousand, vehicle type, so on and so forth. Is that significant? The p-value is 0.000, which is less than 0.05, and therefore I will go ahead and conclude that the model is significant. Let me draw your attention to a couple of important things here. This is the coefficients table. And because I've chosen the enter method, it is producing the coefficient for each and every variable that I have taken. Some of these variables are negative. Some of these variables are positive. These are the unstandardized coefficients. I'm also getting the standardized coefficients and the significance level. Now, what is very, very important here is there are a few variables which are insignificant. Let me just give you one example. Let's take the example of horsepower. Look at the p-value corresponding to horsepower. It is 0.611. The p-value is 0.611, which is greater than 0.05. 0.05 is the level of significance. I'm comparing the p-value with the level of significance. And because the p-value is bigger than 0.05, I can say that horsepower is an insignificant variable. The same argument holds good for the variable width. This because the p-value is bigger than 0.05. Please also look at variables like length, curb weight, fuel capacity. All these variables have a p-value in excess of 0.05. Since the p-value is bigger than 0.05 for several variables, it means that these variables are insignificant. Now, I will have to take the R square with a pinch of salt here. I cannot completely rely on R square because there are many, many variables whose significance value is simply greater than 0.05, indicating that this variable is not contributing significantly. But because we have chosen the enter method, all the variables have been included into the model building process. We have to be very, very careful. How to rectify this problem, I will discuss in my next video. But I'd like to also draw your attention to a couple of points as to what is the difference between unstandardized coefficients and standardized coefficients. This is a very, very important point. What is the difference between unstandardized coefficients here and the standardized coefficients? Now, unstandardized coefficients are used to construct the regression equation, and unstandardized coefficients can be used to build the regression model and get the predicted value of sales. But when it comes to standardized coefficients have a completely different purpose. The word standardized is very, very important here. If I were to ask you a simple question, is 1 kg bigger or is 10 liters higher, right? If you have two variables, that is one variable may be measured in kgs, the other variable is measured in liters. And if I ask you to compare, now you will say it cannot be compared. Why not? For the simple reason that one of the variables, that is weight, may be measured in kgs. The second variable may be measured in liters. You can't compare apples with oranges. The same way here, when you look at price is measured in dollars. When you look at horsepower is measured in a different unit altogether. Wheelbase is measured in a different unit altogether. Some of these variables are measured in dollars, others are measured in cc, some others are measured in centimeters. So you can't compare apples with oranges. So if the goal is to find out which variable is more important, which variable is less important, if you want to compare as to which variable is more important and which variable is less important, don't look at the unstandardized coefficients. Please look at the standardized coefficients. Standardized coefficients are used to compare the model, and the unstandardized coefficients are used to build the regression equation, and you can predict the outcome variable given a set of independent variables. So this becomes very, very important here. Standardized coefficients, you are standardizing the variables, and the idea of standardization comes into picture when you have different variables which are used which are measured in different units. Weight may be measured in kgs, and height can be measured in feet. Salary and such things can be measured in rupees. So you can't compare a variable which is measured in rupees with that of a variable which is measured in kgs. So how do you find out the relative importance of one variable vis-a-vis the other? The answer is, please look at the standardized coefficients. Couple of important points here. When you look at the unstandardized coefficients for vehicle type, you're getting a value of 0.88. When you look at the unstandardized coefficient for price, you're getting negative 0.046. This might give you the impression that vehicle type is more important than price, but you can't compare it like this, because vehicle type and price are not the same. They're not measured in the same unit. A better way of understanding the relative importance of price with respect to vehicle type is to look at the standardized coefficients. When you look at the absolute value of the standardized coefficients, I am using the word absolute, and therefore please ignore the negative side. Look at the absolute value of the unstandardized coefficient for price. It is 0.502. Look at the absolute value of the coefficient for vehicle type. It is 0.2. The absolute value is higher for price. 0.5 is greater than 0.2, which means that price has a bigger impact on sales as compared to vehicle type. So to summarize the discussion that we have had in today's video, we looked at simple linear regression, and then we went on to build a multiple linear regression. We transformed the dependent variable. Why did we transform the dependent variable? Simply because linear regression works best when the dependent variable follows normal distribution. So we worked on log sales rather than sales. Our R-square value improved after transformation. Secondly, we built a linear regression model for sales of different vehicles using the vehicle characteristics like price, vehicle type, engine size, horsepower, so on and so forth. We compared the R-square value for a multiple linear regression with that of a simple linear regression. There is a peculiar problem with R-square, and that is, as you go on adding more and more variables, R-square will go on increasing, even though some of the variables might not be contributing effectively. And therefore, you need to take R-square value with a pinch of salt. Then we interpreted the coefficients of each of the variables, each of the independent variables. This is the table that you're seeing in front of your screen. You are able to see the unstandardized coefficients and the standardized coefficients. We were able to understand what is the difference between standardized coefficients and unstandardized coefficients. Standardized coefficients are used to compare the relative importance of one independent variable vis-a-vis the others. Unstandardized coefficients are used for the construction of the regression equation, which can then be used to predict the outcome value. We looked at the significance values. When we looked at the significance value for each of these independent variables, many of the values were smaller than 0.05, indicating that many of the variables are insignificant. Now, the question is, how do we remove insignificant variables? How do we clean this particular table and go ahead and build the final model with only the best subset of predictors? I've included at least 10 variables. There are many variables which are insignificant. I want to arrive at the best subset of variables which are very, very significant. And I also want a reliable R-square. To answer these questions, I request you to watch my next video, In my next video, I will be answering each of these questions. With this, I will come to the end of today's presentation. I request you to subscribe to my channel. I request you to share this particular video with your friends and relatives. Thank you very much. Have a great day ahead.